So this is 9.4, completing the square, day 1, take 2, since my other video didn't work. All right, because I know all of you care. So we have many ways to solve quadratic equations. We did graphs, we did factoring, completing the square, that's this lesson, and then quadratic formula, next lesson. So in our standard form of an equation or quadratic, we have x squared is plus bx plus c is equal to, and then it's x plus this squared when you factor it. So how do we get from here to here so that it works? By completing the square, you will half of b squared. C, this is where c is, that needs to be half of b squared. Okay, so let's take a look at the problem. I know some of you are confused, hang on. Half of a negative 10, look down here, we get x minus 5 quantity squared. Half of a negative 10 squared is 25. Here, half of 14 is 7 squared 49, and this will always work out to be, just like it has there, half of b right there. So we're always going to be adding half of b squared to both sides when we get to solving an equation. So half of 8 is 4 squared, 16. Half of 22 is 11 squared, 121. Half of 7 is 3.5 squared, 12.25. And half of a negative 3 is a minus 1.5, or as a fraction form, squared, 2.25. All right, so let's take a look here now. So we're going to solve by completing the square. So what are we going to add to both sides? That's what we have to figure out. What number am I going to add to both sides? So half of 6 is 3, squared is 9. So I'm going to add 9 to both sides. Remember, I can factor this left side into, because it's a quantity squared, into x plus, or x plus or minus half of b, in this case 3. So we have x plus 3, quantity squared is equal to, when we add over here, we get 25. And then we do square roots to both sides. So it's x plus 3 is equal to plus or minus 5. Subtract the 3, so we get negative 8 and 2. Take a look here. What number do I need to add so that I will have a perfect square trinomial right here? Well, half of 4 is 2, squared is 4. So I have to add 4. So I have to have a 4. And when I add to this side, I have to add over here to this side. So this factored is x plus 2 quantity squared, and then 16 square roots both sides, and I get x plus 2 and plus or minus 4. Subtract 2 to solve for x, I have to subtract 2, so it's plus or minus 4 minus 2, so I get negative 6 and 2 as my answers. Number 9, same process. We're going to go through the same steps. What number am I going to add to both sides? Well, first of all, I don't want a number here, so I'm going to add 7. That's why I have 7 over here. So what am I going to add to both sides? Half of b squared is 9. So we're going to add 9 to both sides. This is x plus 3 quantity squared is equal to 7 plus 9, 16. Again, how do we get this x plus 3 quantity squared? Because for perfect square trinomial is half of b squared. So this will be a perfect square trinomial, which is x plus 3 quantity squared. 16. Square root of both sides, so we get x plus 3 is equal to plus or minus 4. And then subtract the 3, so negative 4 minus 3, negative 7, positive 4 minus 3, 1. Number 10. Again, get rid of this 30, get it on the other side. So when I do that, it's minus 30. And then half of 14 is a negative 7, right here. Okay. and squared is 49. So I'm going to add 49 to both sides. Adding 49 to both sides. Oh, so then over here I get 19. Then I do the square roots, and I get x minus 7 plus or minus 4.4, round to the nearest tenth if need. So plus or minus 4.4, when I solve for x here, I have to add 7, so I get these two answers. Your assignment is 9.4, page 25, 1 through 21 odds. Now remember, for whatever reasons, I'm at home, things don't quite technology work the way I want it to work, so the PDF, I just gave you the big chapter, or the unit, chapter 9 PDF, so in there you just have to find page 25, okay? It's 9.4, page 25, and you're going to do 1 through 21 odds. Hopefully this video works better, although I'd have to say, when I did my video last time, it was awesome. It just didn't save the way it needed to save, so you guys could watch it. Hopefully this one works. We'll see.